Hello everyone, you are welcome to today's lesson, and in today's lesson we are going to take up from where we left off in our previous meeting. We are looking at probability. In our previous meeting we looked at the various special events. However, we concentrated on dependent and independent events. So today we are going to solve more questions with this concept of dependent and independent events and their rules. So quickly let's look at our next question. Worked example 3. Given that A and B are independent, so you underline this. Remember, anytime you read question, make it a point to underline the salient part. This is very key. If P of A is equal to 0.2, and P of A intersection B is equal to 0.1. Find, P of B. All right, so solution is what you write first. Questions are numbered because we want you to number your solution as well. And even with this one, because the solution is coming directly after this. If you don't write the number, we will know that you are solving this. So take note. All right. So at this point, this is what we need to do. All right. Thanks for prompting me. So we will quickly go and do that, then we'll come back. So now that we've underlined, we have written the question number, solution first, major question number. What do? We go and extract. So given, it's either you write given and you extract, or you just extract. So the probability of A is equal to 0.2. And the probability of what? A intersection B is equal to what? 0.1. Now you are told that the events are what? Are independent. So you know the independent and dependent event deals with what? What you have here, the intersection or end. So here I am going to write this. Because the events are independent, then I'll write, but my P of A intersection B will be equal to what? When they are independent, what would that be? P of what?
P of A times P of B.
Very good, times P of B. I hope you are following. So this will imply that, and you can see that here I have not drawn my conclusion because I needed to do something before. So what do I have? You were given P of A intersection B, and that is 0.1. So you just come and replace 0.1. Is equal to P of A. You are told that it is what? 0.2. Then what are you looking for? You are looking for P of B. So times P of B. So it's just a matter of making P of B the subject. So in this case, you write it again before you divide. However, when I'm writing this, I will write this side on, this particular side here, because that's what I'm making the subject. Not that I'm moving this one to this side and this one to this side. So 0.2 P of what? B over 0.2 will be equal to 0.1 over 0.2. Is my point well made? So now I'll come and write therefore my P of B. I know this will cancel. That will be equal to, you use your calculator, 0.1 over 0.2. 0.5. And because your probabilities came in decimal, it is convenient for you to also conclude in decimal. Is my point well made? You avoid decimals if possible, but here, because we were given decimals, you deal with it in decimal wise. Is my point well made? Are we all fine with the solution?
Yes.
To you are all fine, so we can move on to the next question. So let's look at this question as well. So let's all read through this question. Should I go back?
Yes, please.
Are you writing or you are thinking through?
Please, I'm taking a picture of it.
All right.
Thank you.
You are welcome. And I've told you I'll send you the slides, when we are through with the lesson, so that you use it to prepare for the test. So that was just by the way. So if, such that, so you are giving event X and Y. Okay, such that P of X will be given the probability of event X, probability of event Y, and probability of what? Okay, X union Y. Okay, the union of the two events. Determine whether or not, okay, the two events here are mutually exclusive. Okay, so please tell me what will be your plan if you are asked to determine whether or not the events, okay, are mutually exclusive. X and Y are mutually exclusive. What will be your plan? So, I'm waiting. What will be your plan? Oh. Okay, so here all that you need to know is know the condition for events to be mutually exclusive. Once you have that condition stated, you are more than good to go. Okay, so first of all, let's extract. We know that we need to extract the information. So given after writing solution the question number, let's extract P of X, okay, is equal to 0.12. Okay, then P of Y, the event Y is equal to 0.52, and okay, your P of what? X union Y, okay, is equal to 0.54. Now you know if the events are, so let's state the condition, maybe for your event to be mutually exclusive. So for, okay, mutually exclusive, what is the condition? You know that P of X, okay, union Y should be equal to, help me. Help me.
It will be P of X plus P of Y.
Plus P of Y, very good. So this is the condition. If this condition is not satisfied, then it means the events are not mutually exclusive. Please, are you following?
Yes, please.
So now what you do is come and take one side. So I'll come and write taking, okay, P of X union Y. And that one you know is equal to, what were you given? Is 0.54. Then you go and take the other side too. You are building your argument. Your premise is what you've stated here. If this premise is satisfied, the foundation of your argument is satisfied, you know the conclusion. The positive conclusion is drawn. Otherwise, the negative conclusion. So the second one is taking the other side, which is P of X, okay, plus P of Y. Okay, and we should know P of X, so this will be equal to P of X, we are told is what? 0.12 plus, okay, P of Y, and that we are told is what? 0.52. Okay, please sum this and let's see. Hello, I'm waiting.
0.64.
0.64. Okay, so 0.64. And obviously, this is not the same as this. So you draw your conclusion. Therefore, okay, X and Y, okay, are not mutually exclusive. Do you get the point?
Yes, please.
Yes,
Okay,
please.
Ellen, do you get the point?
Yes, please.
Good. All right. So this will be it. And this is one way of tackling the question. You can also say that, okay, for your event to be mutually exclusive, okay, P of X intersection Y, okay, should be equal to 0. Is that not it? So in that case, when you are quoting the law or the rule, you quote the rule. So this is the alternative approach. Let me see whether I don't have a next slide. Okay, for solution. So I'm squeezing the alternative solution here. So alt. Okay, I can say that, okay, your usual, if your event is not mutually exclusive, then you are going to get P of X union Y to be equal to P of X, okay, plus P of Y, then minus P of what? X intersection Y. So you substitute and make P of X intersection Y the subject. If you don't get 0, then it means the events are not mutually exclusive. You get the point? So I can say that this implies that P of X union Y, I'm told that is 0.54. Okay, it's equal to P of X, which is what? 0.12, plus P of Y, which is 0.52. Okay, then minus P of X intersection Y. You know why you are doing this. You want the intersection to be negative, 0. If it doesn't give you 0, then it means you are not dealing with mutually exclusive events. So we are going to get this to be equal to, you add this, you said we are going to get 0.64 minus P of what? X intersection Y. Okay, and this means that I will say that therefore my P, no, I can't draw my conclusion because my conclusion is not to find X intersection Y or P of X intersection Y. So I'll write, this implies that P of X intersection Y will be equal to 0. Okay, I'll move this one here. So it will be 0.64 minus what? 0.54, and that will give us what? 0.1. Am I right? So your intersection didn't give you 0. So I write therefore, again, X and Y are not mutually exclusive. Is that clear? Since P of X intersection Y is not equal to 0. Is my point well made?
Yes.
Okay, so that's also another way. So whichever, okay, method sits well with you, you try and what? Adapt. All correct? Okay, so the next one, okay, this is what we have. I have the solution already there, so I will just walk you through the solution just to save time. So let's see. Okay, A and B are independent, so you underline that, very critical. So independent events. Okay, with the P of A, P of B given, find P of A intersection B. So quickly, okay, we are going to do the whole of this. So let's see, we extract probabilities given, so you are good to go. All right, now you know, if you read through the question carefully, you can see before you start solving, you don't read the questions in isolation. Read through the entire question, and after reading through the entire question, you realize that you will need, okay, P of A bar and P of B bar. Okay, so when you extract your P of A and P of B, you can equally find P of A bar by using that rule, relationship. So we know that P of the complement is equal to 1 minus P the event itself. So you use that one to find the complement, or the probability of the complement of the event A and the event B, which will respectively give us what we have there. Is that clear? Please, are you following?
Please, can you go back?
Okay, so you can see that this information was just extracted here. I've told you anytime you are given any information that you need, extract. So giving, you extract. But if you read the question, you can see that you are asked to find P of A intersection B. They are, okay, independent. So you'll be multiplying probabilities of the events. Okay, so here too, you know, you multiply P of A by and P of B. Oh, sorry, this is union, so we'll come to that. But I'm talking about the last one. It will be P of A bar times, because they are independent, P of B bar. So it means you need P of A bar, which is the complement, then P of B bar, which is the complement. So after extracting the actual event, come and attach or find the complements of the events, the probabilities, so that where you need to fall on it, you fall on it. Otherwise, if you come and do it here and you know that you need P of A, you now go and write, but P of A bar is equal to, okay, and the other one too, when you need the A bar and the B bar, because you extracted the A bar in this question, okay, the B bar too and the A bar, the next question you have to extract. So here you make it general. So you do it up here so that when A, you need it, you can fall on it because it's a general information now. When B, you need any of the complements, you fall on it, as well as what the subsequent questions. Is that clear? Is my point well made? Especially the person who said I should go over. Are you fine now? Okay, so now we come to A. A, what are we giving? We conclude with the P of A intersection B. If the events are independent, then the intersection here will be end, which is the same as multiplication. So it will be P of A times P of B. Okay, so but you know P of A is given, P of B is given, and that gives you P of A intersection B to be equal to 0.1. So that will be it for what you have here. Now, if you look at what P of what A, that is the B, A complement union B, you know union. Whenever you are quoting the union rule, if you don't have sufficient information to say that you are dealing with a special situation where your intersection is 0, you always quote the general one, which is for the non-mutually exclusive event. So the complement of an event and the equally will satisfy either the mutually exclusive or non-mutually exclusive. So in this case, we quote the non-mutually exclusive one. So P of A complement union B will be equal to P of A complement plus P of B minus P of A complement intersection B. You get it? You get the statements? Hello, are you with me? Hello, are we all fine with this statement here?
Yes, please.
If you are not, please let me know. Because this is coming from just the non-mutually exclusive events, union, or if you want, if you like, all. Okay, so at this point, you are told that the events are independent. So it means anytime you see this, the intersection or end, it becomes multiplication. So this reduces to what we have here. Now you go and substitute all your known parameters, then you solve, and that will give you your P of what A complement union B will be this. Okay, and please take note, anytime you are told that major events, in this case A and B, are independent, any mixture of the events, so meaning the complement of the event will also be independent, as well as what the mixture of the event and any complement, it will be independent as well. So here, don't say that you were told in the question that only A and B are independent. So how come here it is A complement and this is B, but you assumed they are independent, and here it is not an assumption. Please take note, anytime events are independent, the complements will be independent as well as the mixture of the event and any of the complements, they will also be independent. Is that clear? So if you assume, it's not a wrong assumption. Indeed it is a fact. Is my point well made? And if you come to C2, it's the same thing. The complements will also be intersection, so it will be independent. It changes to multiplication, then you solve, and that will be it for what we have there. Any questions? Hello, any questions before we move on to our next one? So this will be your assignment. This is going to be your assignment, so please take note. I will put it on the platform as well for you. All right, so I will go back. So now let's see